Hello and welcome to another master class. In the 8th lesson on polynomials, we will learn about the remainder theorem and the factor theorem. In the previous lesson, we have learned how to calculate the value of a polynomial. We have also learned that the value of a polynomial will depend on the value of the underlying variable. In this lesson, we will now learn what is remainder theorem and what is the factor theorem. Practice makes perfect. As explained earlier, in order to excel in mathematics, you must practice often. Try to do all the problems in the exercises in the textbook as well as the solved example. A couple of problems I explained to get you started. The remainder theorem states that when a polynomial p of x is divided by x plus a, the remainder that will be obtained is given by p of minus a. Note that in using remainder theorem, we do not perform the division to find out the remainder. Let us learn about the remainder theorem by taking a suitable example. Suppose we wish to know the remainder when the polynomial px, which is equal to x square minus 2x plus 1, is divided by x plus 2. The remainder theorem tells us that the remainder obtained will be equal to p of minus 2. Therefore, we have to find p of minus 2 in order to find the remainder when px is divided by x plus 2. Let us therefore find out what is p of minus 2. To find p of minus 2, we must replace x in the polynomial by minus 2. If p of x is equal to x squared minus 2x plus 1, then p of minus 2 is equal to minus 2 squared minus 2 into minus 2 plus 1. Therefore, p of minus 2 is equal to 4 plus 4 plus 1. p of minus 2 is therefore equal to 9. Let us confirm this by performing synthetic division to divide x square minus 2x plus 1 by x plus 2. As can be seen, the remainder obtained by performing synthetic division is the same as that obtained by using remainder theorem. We now come to factor theorem. A number is said to be a factor of another number if on division of the second number by the first, the remainder obtained will be 0. This is also true for polynomials. If a polynomial is divided by another and the remainder obtained is 0, then the second polynomial is a factor of the first. Note that remainder theorem and factor theorem are related to each other. Let us understand the usefulness of the factor theorem by taking a suitable example. Let us try to find out if x plus 2 is a factor of the polynomial p of x, which is equal to x cube plus 2x square minus 3x plus 6. The remainder that is obtained when px is divided by x plus 2 is given by p of minus 2. Therefore, if px is equal to x cube plus 2x square minus 3x plus 6, p of minus 2 is equal to minus 2 cube plus 2 into minus 2 square minus 3 into minus 2 plus 6. p of minus 2 is therefore equal to minus 8 plus 8 plus 6 plus 6. p of minus 2 is equal to 12. Since p of minus 2 is not equal to 0, therefore x plus 2 is not a factor of the polynomial x cube plus 2x square minus 3x plus 6. Let us try to find out if x plus 1 is a factor of the polynomial p of x, which is equal to x cube plus 2x square minus 3x minus 4. The remainder that is obtained when px is divided by x plus 1 is given by p of minus 1. If p of x is equal to x cube plus 2x square minus 3x minus 4, then p of minus 1 is equal to minus 1 the whole cube plus 2 into minus 1 the whole square minus 3 into minus 1 minus 4. p of minus 1 is therefore equal to minus 1 plus 2 plus 3 minus 4. p of minus 1 works out to be 0. Since p of minus 1 is 0, therefore x plus 1 is a factor of the polynomial x cube plus 2x square minus 3x minus 4. Let us now take a look at some problems which require us to find out if one polynomial is a factor of another. We will also learn how to find the remainder when one polynomial is divided by another. Question 1 asks us, show that x minus 1 is a factor of x raised to the power of 32 minus 1 and x raised to the power of 33 minus 1. To show that x minus 1 is a factor of x to the power of 32 minus 1, we must show that the value of the polynomial x to the power of 32 minus 1 is 0 when x is equal to 1. So let px be equal to x to the power of 32 minus 1. Therefore, p of 1 is equal to 1 to the power of 32 minus 1. P of 1 is equal to 1 minus 1. Therefore, p of 1 is equal to 0. Since p of 1 is equal to 0, x minus 1 is a factor of x to the power of 32 minus 1. Similarly, to show that x minus 1 is a factor of x to the power of 33 minus 1, we must show that the value of the polynomial x to the power of 33 minus 1 is 0 when x is equal to 1. Let q of x be equal to x raised to the power of 33 minus 1. Therefore, q of 1 is equal to 1 to the power of 33 minus 1. Q of 1 is equal to 1 minus 1. That is equal to 0. Since q of 1 is also equal to 0, x minus 1 is a factor of x raised to 33 minus 1. Thus we have shown that x minus 1 is a factor of both x to the power of 32 minus 1 and x to the power of 33 minus 1. Question number 2 asks us to find the values of a and b if y minus 4 and y minus 1 upon 2 are factors of a y squared minus 9y plus b. According to the factor theorem, if y minus 4 is a factor of a y squared minus 9y plus b, then the value of the polynomial will be 0 when y is equal to 4. Let py be equal to a y squared minus 9y plus b. Therefore, p of 4 is equal to a into 4 square minus 9 into 4 plus b, and this should be equal to 0 by factor theorem. Therefore, 0 should be equal to 16a minus 36 plus b, or 16a plus b must be equal to 36. Let us call this equation 1. Similarly, according to the factor theorem, if y minus 1 upon 2 is a factor of a y squared minus 9y plus b, then the value of the polynomial will be 0 when y is equal to 1 upon 2. Let q of y be equal to a y squared minus 9y plus b. Therefore, q of 1 upon 2 is equal to a into 1 upon 2 the whole square minus 9 into 1 upon 2 plus b, and this is equal to 0 by factor theorem. Therefore, we get 0 is equal to a upon 4 minus 9 upon 2 plus b. If we multiply this equation throughout by 4, we will get 0 is equal to a minus 18 plus 4b, or in other words, a plus 4b is equal to 18. Let us call this equation 2. When we multiply equation 1 throughout by 4, we will get 4 into 16a plus 4 into b is equal to 4 into 36, or 64a plus 4b is equal to 144. Let us call this equation 3. Subtracting equation 2 from equation 3, we get 64a plus 4b is equal to 144, and minus of a plus 4b is equal to minus 18. From these two, we can say that 63a is equal to 126, or a is equal to 126 upon 63. We get a is equal to 2. Putting this value of a in equation 2, we get a plus 4b is equal to 18, or 2 plus 4b is equal to 18, or 4b is equal to 16. Therefore, b is equal to 16 upon 4, and now we can conclude that b is equal to 4. Our answer to this problem is therefore a is equal to 2 and b is equal to 4. Question 3 asks us to find out what will be the remainder when 3x cubed minus 4x squared plus kx minus k is divided by x minus k. To find out the remainder when the first polynomial is divided by the second, we must put x is equal to k in the first polynomial. Let p of x be equal to 3x cubed minus 4x squared plus kx minus k. Therefore, p of k is equal to 3 into k cubed minus 4 into k squared plus k into k and minus k. Therefore, p of k is equal to 3k cubed minus 4k squared plus k squared minus k. Or p of k is equal to 3k cubed minus 3k squared minus k. Therefore, the remainder that will be obtained when 3x cubed minus 4x squared plus kx minus k is divided by x minus k is given by 3k cubed minus 3k squared minus k. We have now come to the end of this lesson. Let's have a quick recap of what we have learned in this lesson. In this video, you have learned how to use the remainder theorem to find out the remainder when one polynomial is divided by another. We have also learned how to find out whether one polynomial is a factor of another by using the factor theorem. We have also learned in this video how to solve problems which use the remainder theorem and the factor theorem. New videos are being added to my channel every week, so please subscribe. Also click the bell icon below to be notified immediately when a new video is added. In the next lesson, we'll learn how to factorize polynomials. In case you have missed an earlier video, click on the playlist and watch the video again. To visit the masterclass channel, click on the round logo. Don't forget to subscribe and also to click on the bell to be notified immediately when a new video is uploaded. Thank you for watching this video.